All right, hey everybody, Mrs. Slauson again. So at this point, some of you will want to fast forward because some of us got through quite a bit of this. Some of us just got through a little bit. So you need to fast forward to where we left off, but I'll be starting on page 3 in our chapter 3 packet. Remember, the chapter 3 packet looks like this, has the mention about bacon. And again, just fast forward to where you need to be. So what we are doing is we're trying to determine if it's linear or exponential. If you've forgotten everything, you should be looking over your notes from page 2, or you could watch the video from page 2. It's about 6 minutes long, okay? And then you wouldn't have to take the notes, you just kind of listen. So again, what I want to do on each problem is establish if it's linear or exponential, the y-intercept, and in this case, we're also going to write the equation. So assuming that the x's are going up by 1, which they are, what I want to do is focus on is how they go from one y to the next to the next. So from 5 to 3 to 1, they're going down. So what I always check for first is it subtracting? And it is. I subtract 2, subtract 2, subtract 2, subtract 2. So that's going to make it linear with the fact that it's subtracting 2. I want to establish the y-intercept. Again, all y-intercepts are when x is 0, so I can see that here. So I'm going to write 0, 3. If you want to write it as a single number, it's 3. And then since it's linear, I'm going to have a slope. And that slope, again, what we talked about over here, is the m is the amount that they add or subtract each time. So my slope here will be -2. And then I can fit it into the formula of y equals mx plus b. I'll write y. My m is -2, so that number is married to x, and then the number that's by itself is 3. So then I can put the equation in there. So now I want to see, is this one linear or exponential? So from 3/2 to 3, not so great with that. So how do I go from 3 to 6, 6 to 12, 12 to 24? It's getting bigger. So again, I always just look for addition. I'm not adding the same amount, but I am multiplying, and I'm always multiplying by 2. So since it's multiplying, that's going to be exponential. Again, I want my y-intercept, the b. So when x is 0, I see that my y-intercept is 3. And if you wrote it, just by itself, it's 3. And then I want to look for g. And g, if we go back to page 2, known as the growth factor, that's what you multiply by each time. So this 2 that I have here is going to be my g. And now to have that fit this format, it's going to be y equals b, so b is 3, and then in parentheses I'll put 2 to the x. So what was asked in some of the questions is, can we turn this into 6 to the x? Well, if you turn it into 6 to the x, so don't write this down because it's not correct, then I need a y-intercept. And I need to be able to have something so that when it multiplies to this, it still stays that. And the number you can multiply that doesn't change your original value is 1. So when I look here, this is saying that my y-intercept is 1, but it's not. Up here it's 3. And then this is saying that it's multiplying by 6 each time, which I'm not. So you never multiply these. B and G will never combine into one number. They are separate. All right, number 6. So this time I'm going down. So I would like to say, subtraction, but I'm not subtracting the same amount. So it is exponential, but exponential is when you multiply something. And it's hard to see that. So what most of us will probably see is that we are dividing by 2, dividing by 2. 5 divided by 2 is 5/2. 5/2 divided by 2 is 5/4. So you're dividing by 2. And the reference I made on this is that, if I have a piece of paper here and I want to divide it in 2, what I'm going to do is rip the paper, and then the word that followed with most people was in half. And when you divide by 2, that means you are multiplying by half. So that is my multiplying amount, and that will be my g. And then my y-intercept, again, is when x is 0. So as an ordered pair, it's 0, 10. Standing alone, it's 10. And now I can have it fill in this format. So again, it's y equals b, so 10. In parentheses, I'll do the half to the x power. And the half isn't always important. The parentheses aren't always important. If the number that you are putting in there is just a whole number, 2, 3, 4, 5, 6, 7, 8, 9, 10, you don't need the parentheses. But if it's a fraction and we're going to be working with the calculator, you do need that in parentheses. Okay? All right, so 7, 8, 9. So I know this is exponential because it's curved, linear, and exponential. I'm first going to establish my y-intercept. So this one is 4. And as an ordered pair, that's 0, 4. Let's just do that on all the problems. Here my y-intercept is -3 or 0, -3. And on this one it's 1, 0, 1. So let's start with the linear. That's the easiest. So I need an m. So with this one, since there is a picture, I think it's easiest to find the slope by just counting my rise over my run. And you're going to count how many you rise and how many you run to get from one nice point to another nice point. And the nice points are actually these dots. They don't always put the dots, but what you want to look for are what they call lattice points. So when they have the grids on here, like this is a nice point, nice point, nice point, but I wouldn't pick something like right in here, all right? I can tell what the coordinates are from the grids, and so those are what I call the nice points. And you always want to look at the scale. So my scale is by ones, either ways, either x-axis or y-axis. So I'm going to rise 2, run 1, rise 2, run 1. So if I rise 2 and run 1, we can just divide that, and that's our slope. Okay? And now we can write our equation. We can fill in y equals mx plus b. It's going to be y equals m, so 2 is married to x, and I want -3 to be alone. And you can also write it as 2x minus 3. That's totally up to you. So let's go for exponential. We're going to start at this one. So here with g, I want to see what they're multiplying by, and that's a little tough. So what I'm going to do over here is make a table, and I'm going to make my table so that I have the x values going up by 1. So let's see, I've got -1, and they give me a point for x is 0, x is 1, x is 2, x is 3. So I'm going to fill that in. And then I'm going to write down the ones that I definitely know. So I know if x is 0, I got 1. For x is 1, my y value is 2. For 2, it's 4. And for 3, it's 8. And so since it's exponential, that means they're multiplying by the same amount every time. So it appears that I'm multiplying by 2. 1 times 2 is 2. 2 times 2 is 4. 4 times 2 is 8. And if you do want to figure out this number, you can just work the opposite. And if they're multiplying by 2 this way, I'll just divide by 2, because 8 divided by 2 is 4. 4 divided by 2 is 2. And 1 divided by 2, 1 divided by 2 is a half. And that is what that point is, -1/2. So my g is this multiplying by 2 amount. And now to fill this in, I got y equals b, so the 1, times g, 2 to the x power. And usually, though, you actually wouldn't see the 1 because 1 times 2 to the x is 2 to the x. So just be aware of that. All right, on this one, again, what I'm going to do is, sorry, I'm going to move this, figure out what these are. So I need to make my table, and I got -1, 0, 1, 2, 3, so I'm going to do that, -1, 0, 1, 2, and 3. For -1, I've got 8, for 0, I got 4, for 1, I got 2, for 2, I got 1, and for 3, I don't know. So what I want to look to see is what are they multiplying by. And in this case, again, they're not multiplying, they're actually dividing. In my head, 8 divided by 2 is 4, 4 divided by 2 is 2, 2 divided by 2 is 1, 1 divided by 2 is a half. But when I have g, it can't be a dividing number. So remember, dividing by 2, we already talked about, is the same as multiplying by a half. So that is my g value, a half. And now I'm going to write my equation. It goes y equals b, so that's the 4. In parentheses will be the 1/2. Sorry, you can't see that, to the x power. And again, you cannot multiply these. This is the y-intercept. This is what it multiplies by. If you change it, you're changing the y-intercept and you're changing the growth factor. And then we're going to move to page 4.